Hello and welcome. You've found your way into a quiet space, a place where curiosity is allowed to stretch out and settle in, where big questions don't have to be answered right away, and where wonder is given room to breathe. If you're winding down for the night, or simply letting your thoughts drift before sleep, I'm glad you're here. Tonight we're going to follow a question, not a quick one, not one with a simple yes or no at the end, but a question that opens up as you walk with it, a question that invites you to look at the familiar world with unfamiliar eyes. What if Earth was designed? Not designed in the way we think of furniture or phones or bridges, where someone draws a blueprint and then assembles parts one by one. Not that kind of design. More the broader idea, what if the planet we live on and the conditions that keep us alive weren't simply the product of blind chance and chaotic physics, but the result of some guiding principle? Whether that principle was a conscious mind, a deep natural algorithm, or something stranger still, that part is up to interpretation. The point isn't to prove or disprove, but to explore. To notice what we often overlook. To see patterns not as evidence for a verdict, but as invitations to think differently. So let's take this slowly. No rush. Just a quiet walk through the landscape of the idea. Think about your ordinary morning. Light seeps through the window, soft and warm, not too harsh, not too faint. You inhale, and the air you breathe, made of gases in exactly the right balance, slips into your lungs, delivering oxygen to your blood, as if the two were made for each other. You feel thirsty, and water, clear and abundant, is right there waiting to quench you. Step outside and the world feels strangely calibrated. The pull of gravity lets you walk easily, neither floating away nor crushed into the ground. The temperature, though it changes, usually stays within ranges that let your body adapt. Plants grow, animals stir, clouds drift across the sky. All of it feels ordinary, but pause, and it starts to look uncanny. Every piece just happens to fit together. The light, the air, the water, the soil. Could all of that truly be coincidence? Science has an answer, of course, a very good one. We know about planetary formation, about the chemistry of stars, about the long chain of events that stretched over billions of years to produce this planet. We know about the solar system's early chaos, the collisions, the cooling, the slow stirring of life from non-life. These explanations are rich, supported by data and models. And yet, even within that framework, there are moments where you stop and think, isn't it a little too convenient? Earth orbits a stable star. Not too young, not too volatile. Our planet sits in what's often called the habitable zone, the right distance for liquid water to exist. That alone seems fortunate. But then the details pile up. Earth's tilt, which gives us seasons without plunging us into extremes. Its spin, which smooths out temperatures between day and night. The presence of a large moon, unusual for a planet this size, steadying that tilt and driving tides. The magnetic field, generated deep within, shielding us from harmful radiation. The precise mix of gases in the atmosphere, supporting respiration and photosynthesis. The balance of ocean and land, creating diverse climates and ecosystems. Each factor could have been different. And if even a few had been different, life as we know it might never have appeared. There's a tidy way to explain this. It's called the anthropic principle. Of course, the universe looks suited to life because we're here to observe it. If conditions weren't right, we wouldn't exist to wonder about them. But that explanation, neat as it is, doesn't quite still the curiosity. Because it doesn't address the deeper itch. Why did the conditions line up at all? Why do the numbers fall into the narrow bands that permit not only survival, but flourishing? Noticing patterns isn't proof of purpose, but it does raise questions. Humans are pattern-seeking creatures. We're wired to spot order in a sea of noise. When we see symmetry in a flower or balance in a face, it feels right. Our brains light up. Why is that? Why should a universe born from randomness produce so much order? Why should what we call beauty so often align with what's efficient, functional, even mathematical? Take the spiral in a seashell, the branching of a river, the swirl of a galaxy. The same forms echo across scales from the microscopic to the cosmic. They're efficient shapes, yes, but they're also deeply pleasing to the eye. Does that mean the universe is tuned not just for life, but for recognition? Does it mean anything at all? Maybe not, but it's striking nonetheless. Step further into biology and the impression deepens. Proteins fold into precise shapes, each one enabling a function. DNA encodes instructions with a 4-letter alphabet, compacting meters of information into microscopic cells. Communication between cells, organs, and systems hums with coordination. Evolution explains much of this: variation, selection, adaptation over time. The body isn't flawless, far from it. But it works. It works so well that even its flaws can feel like part of a larger story. And the language we use to describe it often blurs the line between science and metaphor. DNA as code, the cell as a factory, the brain as a computer. These aren't literal, but they're telling. We can't help but describe life in terms of design, because the structures we encounter are so intricate, so layered, so efficient. Does that mean someone or something drew up plans? Not necessarily. It might mean that the rules of chemistry and physics naturally bend toward complexity, toward systems that sustain themselves, toward structures that resemble intention even when none exists. Long before telescopes, long before laboratories, people gazed at the sky and asked similar questions. They imagined the world spoken into being by voices, carved by gods, shaped by spirits. Creation myths arose not because people had data, but because they felt instinctively that such order must have a cause. Modern science replaced those myths with models built on observation and experiment, and those models have been extraordinarily successful. They let us predict eclipses, cure diseases, send spacecraft to distant planets. And yet, the question never really disappeared. Even as science advanced, the impulse to wonder remained. Why this planet? Why these rules? Why this version of reality when countless others might have been possible? Zoom out, and the coincidences grow larger. Stars forge carbon in delicate processes that could have failed if the laws of physics were even slightly different. Gravity, electromagnetism, nuclear forces all have values that sit in tight ranges. If they were weaker or stronger, matter as we know it might not exist at all. Is that chance, or is it something else? Some scientists propose the multiverse, countless universes, each with different rules, and we happen to live in one that permits life. Others imagine a deeper structure, laws beneath the laws, that constrain reality into what we see. Neither idea resolves the mystery. Both simply move the question back a step. Why this framework? Why these numbers? Why something instead of nothing? The truth is, no telescope, no microscope, no equation has yet given a final answer. And maybe it never will. But maybe that's not the point. The point is in the asking, in holding a question without rushing it to closure, in noticing how Earth, with all its balances and systems, behaves in ways that feel tuned, whether by design or by chance. Because even without certainty, the fact remains, here we are, on a planet that holds water in its rivers, oxygen in its air, warmth in its sunlight. A planet where minds have arisen capable of wondering about design at all. That in itself is remarkable. When you shift your attention from the surface of Earth to the engine beneath, the picture changes from landscapes and weather to something slower, deeper, and far more patient. The crust we stand on is thin, astonishingly thin, riding atop a mantle that moves like a very slow ocean of rock. Over years it looks still. Over ages it flows. That motion, plate tectonics, is one of the planet's most consequential habits. Plates collide and crumple into mountain ranges. They pull apart and ooze new crust along mid-ocean ridges. One plate dives under another, ferrying water and carbon downward, where heat and pressure transform them, then send them up again through volcanoes, back to the air, the soil, the sea. Seen up close, it's messy, earthquakes, ash, fault lines. Seen from a distance, it's a great circulatory system. Without it, Earth would flatten under erosion, nutrients would lock away, climate would drift without the checks and balances of long-term carbon cycling. With it, the surface remains diverse, stocked, habitable. Not perfect, habitable. The balance here is delicate. If the mantle were too stiff, the surface would seize up. Too soft, and the crust would break and churn too fast to stabilize. This middle place, this slow carrying sway, lets continents wander just enough to sculpt climate and evolution without erasing the stage altogether. It's an old rhythm that life has learned to dance to, even when the steps lurch. And then there is water, the planet's most fluent architect. We say water finds a way, but more precisely, water finds every way. It dissolves and delivers, it cushions and cuts, it climbs the air as vapor and returns as rain, a patient courier cycling heat and nutrients through the world. Water also has a small repertoire of unusual tricks that turn out to matter enormously. It carries heat without changing temperature quickly. It becomes less dense as it freezes, so lakes ice from the top down, protecting the life beneath. It's transparent to the same gentle band of light our star pours into the sea, allowing photosynthesis to reach below the surface. You can analyze each trait with chemistry, and the explanations are sound, but step back and the ensemble feels purposeful, as if a handful of quirks were quietly rehearsed into a life-supporting performance. Watch water write its signature across a landscape and you'll see another theme, branching. Rivers split, merge and braid. Tributaries spread like veins. Up close, every channel seems to choose its own path. From far away, the pattern repeats, a fractal tree inscribed into the skin of the planet. Fractals appear wherever things need to move efficiently. Blood through the lung, sap through a forest giant, charge through lightning, wind through a canyon maze. The repetition across scales isn't a coincidence, it's a solution. When the world is tasked with reaching many points from one source using minimal material, similar shapes emerge again and again. You don't have to invoke intention to get them. You also don't have to ignore how intentional they look. Consider a seed head of a sunflower or the spiral of a nautilus shell. The angles and ratios that pack seeds or add new chambers are not chosen for beauty, and yet they arrive at what we call beautiful. The Fibonacci spiral, the golden angle, forms that balance compactness with growth, stability with expansion. Plants that happened upon those forms made better use of space and light. The forms remained. Over time, our eyes learned to relax into them. Efficiency and aesthetics, function and form converged. Beyond water and pattern, a presence much closer to home, so close we almost forget it, keeps time with our tides and steadies our seasons. The moon. For a rocky planet, a moon this large is unusual. Its origin story is dramatic. An infant Earth collided with a Mars-sized body. The debris ring gathered and cooled. A companion was born. If the angles had been different, if the impact had been too small or too large, we might have had no moon, or a ring that never coalesced, or a companion too chaotic to help. Instead, we have a singular lantern in our night that does several quiet jobs. It tugs at the oceans, creating tides that stir coastal life and drive wet-dry cycles along shorelines. cycles that may have nurtured early chemistry on its long walk toward biology. It steadies Earth's axial tilt, keeping our seasons regular enough for migratory paths to persist, for forests to synchronize, for climate to stay within bounds, broad enough for adaptation, but narrow enough for continuity. And very slowly, it lengthens our days, tidal friction turning an ancient 6-hour spin into the human-friendly 24. The moon is no tender deity, it is a rock in motion. Yet its consequences have been tender to us. Step back, farther still, and the stage lights widen to show the quiet structure beneath everything: gravity. It doesn't demand attention, it doesn't flash or hum, it simply insists. It presses dust together until a planet appears, sorts heavy metals to the core and lighter rocks to the crust, draws oceans to lie flat and rivers to run downhill. Gravity is weak compared with other forces, but it is always on, everywhere, on everything. That relentlessness makes it the universe's organizer, the unhurried hand that shapes spheres from rubble and keeps Earth on a near-circular path where sunlight arrives predictably. Predictability matters. Life leans on cycles, day and night, season and season, tide and tide. A stable, nearly round orbit keeps solar energy from whipsawing between extremes. Earth's tilt, moderated by the moon, paints the year with gentle gradients. Winter that yields, summer that recedes, springs and autumns that cue growth and rest. The predictability is not absolute. Ice ages come and go, droughts stretch thin, storms redraw coasts, but the frame holds. It has held long enough for forests to climb mountains and retreat, for coral to build cities, for animals to map migrations across centuries of memory. People often point to a phrase, the habitable zone. It's a simple picture, an annulus around a star where liquid water is likely. But the zone is only the doorway. On either side of Earth, the planets offer a caution. Venus scorched by a runaway greenhouse, Mars frozen and scoured by radiation after its magnetic shield failed. Our world threaded a narrow path: distance, atmosphere, magnetism, tectonics, water. So the door didn't just open, it stayed open. The word for that is not perfection. The word is durability, which brings us into the atmosphere we live inside every moment. A thin film by cosmic standards, but an ocean of air to us, layered, moving, self-adjusting. About 4 parts in 5 is nitrogen, a 5th is oxygen. Trace gases, argon, carbon dioxide, water vapor, and a whisper of others tip the balance of heat, growth, and weather. Too much oxygen and fire eats the world. Too little and lungs fail. Too much carbon dioxide and the planet bakes. Too little and photosynthesis falters. Add to that the ozone's ultraviolet shield, the pressure that lets water remain liquid, and winds that ferry moisture and seed and dust between continents. Each piece ordinary in its physics, extraordinary in its fit. The atmosphere doesn't sit still. Jet streams steer storm tracks. Trade winds move heat from equator to pole. Monsoons pulse with the heartbeat of land and sea. What looks like chaos from a weather map resolves in the average into a set of constraints that life learns to expect. Migration routes, flowering seasons, insect emergencies, they're all calendars written in air. All of which may sound like a case for design, but it is just as easily a case for emergence. Systems with feedback settle into ranges. Iteration finds workable patterns. Selection, whether biological or physical, keeps what survives. We don't have to claim a blueprint to admire how much coherence the world accomplishes with only rules, time, and the willingness to try again. And yet when you step into the cell, the sense of coherence sharpens. DNA is not only storage, it is instruction. Inside a nucleus, 2 meters of human genetic material fold into a space far smaller than a dust mote, arranged so that the right recipes can be read at the right time. Enzymes accelerate reactions that would otherwise be languid to the point of uselessness. Molecular motors shoulder cargo along microscopic tracks, hauling and sorting and repairing. The whole enterprise looks to our tool-making eyes like a city: factories, couriers, switchboards, maintenance crews, traffic rules. Evolution is the planner, chance is the contractor, success is the building code. The result is not flawless, it is resilient. When pieces break, backups engage. When signals misfire, edits attempt repairs. When damage accumulates, some cells retire for the good of the whole. Origin stories at this scale are naturally foggy. How did the first replicators arise? How did membranes self-assemble? How did metabolism boot up without instructions? The hypotheses are many: mineral surfaces templating molecules, deep sea vents providing gradients, ice films concentrating reactants, perhaps several paths braided together. However it happened, somewhere between warm pond and vent field, between lightning and tide pool, chemistry crossed the threshold into something with memory. From then on, the story became cumulative. Memory allowed variation. Variation invited selection. Selection wrote a long letter called life. None of it was smooth. Extinctions slammed doors, others opened. The atmosphere flipped from oxygen poor to oxygen rich, a catastrophe for some, an invitation for others. Continents scattered and reassembled, oceans funneled heat along new corridors, mountain ranges rose and taught rain where to fall. Through it all, feedback loops, a phrase that sounds cold but in practice is generous, kept Earth within a swaying corridor where adaptation could keep pace with change more often than not. There's a temptation when you trace these lines to ask the big question too soon, to jump from pattern to purpose, from function to intention. But pausing is part of the work. When you pause, you begin to notice a subtler story running in parallel to fine-tuning, the story of just enough. Earth is not optimized, it is serviceable. Bodies have blind spots, backs ache, knees complain about stairs our ancestors didn't climb, forests burn, then learn, then burn again. Rivers flood, reset their banks, deposit new soil, invite a new sequence of life. Just enough is not a slogan, it's a survival strategy. Robust because it allows error, generous because it tolerates noise, creative because it keeps options open. That phrase, keeps options open, touches something central. A tightly engineered world, perfectly tuned and perfectly locked, leaves little room for surprise. But an emergent world with slack and sway, with tolerances and toleration, leaves room for novelty. Eyes evolved many times in many forms. Navigation arose as magnetic sense here, as echolocation there. Sociality bloomed in ants and whales and primates by very different routes. When a planet offers steady cycles and stable energy, and also rough edges and pressure points, explores the balance between comfort and challenge. It tests, stumbles, tries again. Over deep time, the library of workable solutions becomes a forest of possibility. And this returns us to rhythm. Earth is not just a place, it is a pace. Circadian clocks tick in cells that have never seen the sun. Annual pulses run through migrations and blooms. Deeper cycles, the wobble of Earth's axis, the slow stretch of the day as the moon glides away, whisper across epochs. Even stars have moods, the sun's 11-year heartbeat in flares and spots, an irregular drum that still finds ways to matter at the margins. Layer these cycles and you get scaffolding for story, a reliable backdrop against which life can improvise without losing the theme. You can choose to call that design. You can choose to call it nature's way of converging on stable forms. Either way, what we're watching is coordination without a conductor, music that stays together because each instrument listens, adjusts, and keeps to time. There's a passage too about humility. If the moon had not steadied the tilt, if the core had cooled too quickly and the magnetic shield collapsed, if the atmosphere had slipped away on the wind of a harsher star, if water had not floated when frozen, if carbon had not found its sweet spot in stellar furnaces, if. A chain of ifs doesn't obligate belief, but it does invite gratitude. The story we live inside is contingent, which makes it both fragile and precious. And the more carefully we attend to the contingencies, the more clearly we see how our lives depend on balances we do not control. So tonight, as you let your thoughts slow, imagine the world not as a machine locked into purpose and not as a lottery ticket that happened to pay out, but as a conversation. Rock speaks to air in weathering, air speaks to ocean in storm. Ocean speaks to land in tide, land speaks to life in soil. Life answers back with forests that cool, reefs that build, microbes that braid the chemistry of breath. The conversation is not polite. There are arguments, failures, long silences, but it persists. And persistence at planetary scale is a kind of wisdom. In the next chapter, we'll step even closer to that conversation, into DNA's grammar, the way cells compute without knowing what computation is, and how eyes, ears, and hands became astonishing instruments for a mind to meet the world. We'll also linger with timing, why when is as important as what, and how evolution doesn't just invent parts, it learns to coordinate performances. For now, you might simply notice your own rhythms syncing to the larger ones, breath slowing, thought softening, the body's clock listening to the turning earth. Even if the question of design remains open, the experience of belonging does not. You belong to these cycles, and they, in turn, make room for you. Rest and let the planet keep time. When you shrink the frame from landscapes and oceans down to the scale of a single cell, the sense of structure doesn't fade, it sharpens. At this level, the world is busy in ways invisible to our eyes, yet essential to everything we are. Inside every cell is DNA, a long coiled molecule that carries the instructions for life. If you stretched out the DNA in one human cell, it would measure about 2 meters, yet it's packed neatly into a space so small that thousands of cells can fit on the head of a pin. How does it fit? By winding around proteins, folding into loops, layering upon itself, an astonishing feat of organization. DNA doesn't just store data, it acts like a code written in 4 chemical letters: adenine, thymine, cytosine, guanine. These letters form sequences that are read and translated into proteins, the workhorses of life. Those proteins fold into 3-dimensional shapes that allow them to act as enzymes, motors, messengers, and building blocks. The folds are precise, one wrong shape, and the function disappears. And yet, inside living cells, this folding happens reliably, millions of times a day. Watch closely, and the cell begins to look like a factory, not in metaphor, but in process. There are assembly lines where proteins are stitched together. There are checkpoints that ensure quality control. There are couriers, molecular motors, that walk along microscopic tracks carrying cargo from one compartment to another. Some spin like turbines, pumping ions across membranes. Others act like gates, opening and closing to control flow. And all of this is happening inside a structure so small that you cannot see it unaided. Billions of these factories collaborate inside your body every moment, maintaining balance, repairing damage, adapting to change. It's tempting to call this design. The comparison is natural, but it may also be something subtler: emergence, systems that work, endure, systems that fail, vanish. Over time, what remains looks carefully chosen, even if no chooser was present. Where did DNA come from? That remains one of science's deepest puzzles. Perhaps life began in the warmth of hydrothermal vents, where minerals catalyzed reactions. Perhaps it started in shallow pools where evaporation concentrated molecules into self-replicating chains. Perhaps ice, by slowing reactions, offered a cradle for fragile beginnings. Each hypothesis has its strengths, none yet has full proof. What makes the problem difficult is that life requires not only molecules but systems, ways to copy, to regulate, to evolve. Chemistry on its own is not enough. It needs memory, variation, and selection. Somewhere between random molecules and working cells, the spark caught. To some, that spark looks like chance, refined by time. To others, it looks like intention. Either way, the result is the same. A molecule capable of writing instructions, adapting them, and carrying them forward for billions of years. The language metaphor isn't just convenient, it's apt. DNA sequences act like words grouped into genes. Some sequences serve as punctuation, telling the cell when to start and stop reading. Others act like editors, regulating how much of a protein should be made. Some sections were once dismissed as junk, but are now understood to influence expression and structure. All living organisms, from bacteria to humans, share this same genetic code. The same triplets of letters, called codons, correspond to the same amino acids. This universality suggests a common origin, one script, carried forward into every form of life. Scientists have even tested whether the code is optimal, and the results suggest it's surprisingly efficient at reducing errors and maximizing flexibility. Not perfect, but close. It's one of those places where science and wonder meet. We didn't invent the code, we discovered it. And when we did, it looked eerily like something we might have designed ourselves. Evolution explains how DNA changes, how variation arises, how natural selection filters the useful from the useless. The evidence is clear: fossils, shared genes, observed adaptations. But within that process, there are features that stand out. The eye, for example. Light passes through the cornea, the lens focuses it, the retina transforms it into electrical signals, and the brain interprets them as images. The system isn't flawless, there are blind spots, distortions, but it's remarkably effective. Other creatures push vision even further. Eagles spotting prey kilometers away, shrimp detecting polarized light, cats navigating in near darkness. Or take echolocation in bats and dolphins. High-frequency calls bounce off objects, and the returning echoes create a detailed three-dimensional map, all processed in fractions of a second. Evolution traces these abilities step by step, but their present form feels less like trial and error, more like artistry. And then there's the human hand: bones, tendons, muscles, nerves, all working together. The opposable thumb allows precision grips. The fingertips can sense textures at a microscopic level. With practice, hands perform feats. Machines still struggle to imitate, playing a violin, tying a knot, typing words you're reading now. These systems didn't appear all at once. They evolved gradually through countless small steps. Yet in their current form, they seem improbably well suited, good enough to inspire metaphors of design. The body isn't flawless. Spines ache, knees wear out, the esophagus shares a path with the airway. These imperfections make sense through evolution. They're compromises, not clean-sheet designs. But even here, resilience shows through. Skin heals, bones knit, the liver regrows, the brain rewires itself, forming new connections when old ones are lost. Life isn't about perfection, it's about persistence. Even at the level of immunity, precision and improvisation coexist. The immune system recognizes threats, remembers them, and adapts. It's not always accurate. It sometimes mistakes harmless triggers for dangers, leading to allergies or autoimmunity, but its flexibility allows survival in a world filled with shifting threats. That blend of flaw and brilliance raises a curious thought. If Earth was designed, the design doesn't aim for perfection. It seems to aim for good enough to continue. In other words, resilience. Sometimes history turns not on gradual shifts, but sudden jolts. About 66 million years ago, an asteroid struck Earth, wiping out the dinosaurs and clearing the ecological stage for mammals to rise. Without that collision, humans might never have existed. Billions of years earlier, single-celled organisms began producing oxygen as a byproduct of photosynthesis. At first, oxygen was toxic to many forms of life, but eventually it enabled more efficient energy use, paving the way for complex organisms. Even the very existence of complex cells may trace back to an accident. One cell engulfing another, not as prey, but as partner. That merger gave rise to mitochondria, the powerhouses of our cells. Without it, large, energy-hungry organisms like us might never have appeared. Accidents, yet transformative. Events that look chaotic up close, but in hindsight appear almost as if timed. Life on Earth has endured billions of years, but only because a long sequence of conditions held steady within narrow ranges. If the Earth was slightly closer to the Sun, oceans might have boiled. Slightly farther, they might have frozen. If gravity were weaker, the atmosphere could have drifted away. Stronger, and the planet might have collapsed inward. Change any one constant by a fraction, and the system falters, and yet here we are. Not in a perfect world, but in a durable one. Not in an elegant design, but in a survivable one. The word fine-tuning often arises here. Perhaps it suggests intent. Perhaps it simply reflects how precise physics is. Either way, it reminds us how thin the margins really are. From DNA and proteins, from cells and organs, from vision and touch, something else has emerged. Consciousness. A brain layered with motor control, memory, language, imagination. Billions of neurons firing in patterns that create thought, self-awareness, even wonder about design itself. Consciousness may be the strangest product of all. Not necessary for survival in the strictest sense, plenty of life thrives without it, but powerful enough to reshape the planet. It allows us to reflect on the rules we live under, to build tools, to ask questions like this one. And here's the curious loop. We are products of Earth, wondering whether Earth itself is a product. Consciousness lets the system look back on itself, ask if its own existence implies design. That reflection is both unsettling and profound. So, was all this designed, or did it emerge naturally through blind processes refined by time? The evidence supports emergence, yet the outcomes look so coordinated, so structured, that the language of design persists. Perhaps the truth lies somewhere else entirely. Maybe design and emergence aren't opposites. Maybe what we call design is what happens when systems explore possibilities until they find stability. Maybe what we call emergence is the path that gets them there. Whichever words you prefer, the result is the same. Earth works. Life continues. The patterns persist. And we, fragile yet aware, sit inside the conversation, both participants and observers. As the night deepens, imagine this. Every breath you take is part of an atmosphere shaped over billions of years. Every beat of your heart is timed by cycles written into DNA. Every question you ask is made possible by neurons firing in patterns no less real than the stars above. Whether designed or discovered, built or emerged, the fact remains. You are here. And in that simple truth lies a wonder larger than any answer. From the beginning, humans have looked at the world and wondered, where did this come from? The stars moving across the night sky, the regular return of seasons, the strange balance between storm and calm, all of it invited explanation. At first, those explanations were personal. Storms belonged to gods of thunder, crops answered to spirits of fertility, mountains and rivers were carved by ancestors or divine hands. In these stories, the world was intentional, alive with meaning, shaped by beings who acted with purpose. Centuries passed, and philosophy shifted the frame. Some thinkers in Greece spoke of a prime mover, a mind that set everything in motion. In Asia, others imagine the universe not as a product but as a process, an unfolding harmony. Later, the great religions told stories of deliberate creation, worlds spoken into being, skies stretched out like a canvas, oceans divided from land. Then came science, offering a new kind of story. Planets formed from gas and dust. Life evolved from simple to complex. Structures emerged through feedback, selection, and time. No overseer required, just rules and persistence. The picture grew less mythic, but no less astonishing. And yet, even as science replaced the old stories, the impulse to see design never left. Because the outcomes, the balance of Earth's orbit, the precision of DNA, the beauty of symmetry, still whisper of order, of purpose. Not proof, not evidence, but suggestion. The eye works like a camera. The brain works like a computer. DNA works like a code. These aren't literal truths, but metaphors that keep appearing because the systems resemble the ones we build ourselves. And in recent years, the resemblance has grown sharper. We now create algorithms that learn, evolve, and surprise us. Machines write, paint, predict, and design. Not because they're conscious, but because they process structure. They explore possibilities, and sometimes they find solutions no human would imagine. That raises a strange echo. If simple rules in computers can produce surprising outcomes, why couldn't simple rules in nature do the same? And if they can, is design always conscious? Does order always require a mind? Some thinkers take the analogy further. They wonder if the universe itself might be a simulation, not metaphorically, but literally. A digital environment running on some substrate we cannot see. It sounds like science fiction, but it has become a serious philosophical hypothesis. The reasoning goes like this: if civilizations can eventually simulate consciousness, they may run countless versions of reality. If that's true, then statistically most observers would exist inside simulations rather than in the original universe, which means we might be simulated ourselves. There is no direct evidence for this, but physics is filled with odd boundaries, energy that comes in discrete packets, matter that flickers between possibilities until observed, constants that look suspiciously like settings. To some, these features resemble the artifacts of computation. To others, they're simply the way reality works. Either way, the idea forces perspective. If the universe behaves like a system, then perhaps we can study it like one, not to prove intention, but to recognize structure. Science excels at prediction. Gravity tells us where a planet will be tomorrow. Chemistry tells us how molecules will react. Evolution explains how life changes across generations. These models work not because they explain meaning, but because they explain outcomes. But meaning itself, why there is something rather than nothing, why laws exist at all, remains beyond the reach of telescopes and microscopes. Into those spaces, humans bring faith, philosophy, or story. Not to replace science, but to sit beside it. Even scientists use words like elegant, beautiful, or fine-tuned to describe equations. Those words are not measurements, they're reflections of awe. They show that wonder still lives at the heart of even the most precise inquiry. If Earth is designed, why is it like this? Why earthquakes, disease, extinctions, flaws in the spine, blind spots in the eye? Why a world that sustains life but also allows suffering? Perhaps because the system isn't aiming for perfection. Nature doesn't optimize for elegance, it optimizes for survival. Evolution works with what's available, not what's ideal. Systems emerge because they're good enough, not flawless. That may disappoint those who imagine design as neat, clean, and kind, but it also reframes the idea. Maybe design, if it exists, isn't about perfection. Maybe it's about resilience, adaptability, persistence, A system that can break and recover, collapse and rebuild, suffer and endure. So where does that leave us? Somewhere in the blur, between science and faith, between randomness and purpose, between design and emergence. Maybe those aren't opposites at all. Maybe design is what happens when systems find stability. Maybe emergence is what design looks like when it isn't planned in advance. Maybe the distinction is less important than we think. What matters is that the world works, that Earth continues to spin, to breathe, to grow forests and oceans, to host beings who can ask these questions. Perhaps the most profound outcome of all is not the structure of Earth, but the fact that we are here to notice it, that we can measure orbits, decode DNA, wonder about purpose, build tools, make mistakes, and dream. That loop, life becoming conscious of life, is rare enough to feel miraculous, whether or not anyone intended it. And so the question remains, what if Earth was designed? Maybe it was, maybe it wasn't. Maybe the truth is stranger still. But even without an answer, the asking changes us. It reminds us to look closely, to notice patterns, to marvel at the fragile balance that allows us to exist at all. As you listen now, the Earth keeps turning. The moon drifts silently across the sky. Oceans move with the pull of unseen tides. Forests breathe, glaciers shift, and the atmosphere holds steady above your head. You don't need to solve the mystery tonight. You don't need to decide whether the world is built or emergent. It is enough to notice that it is here and that you are here with it. So let the question settle, let it rest alongside you. Whether designed or discovered, the world remains astonishing, and you, listening, breathing, aware, are part of that astonishment. Sleep well. Tomorrow the patterns will continue, and the question, the good one, will still be here in the morning. Good night.